we drew a coordinate, okay? We then found our third side and we did 6 trig ratios. That's what we did on Friday. All right? Today, it's going to be the same thing. You're either going to get xy, or you're going to get yr, or you're going to get xr, and you're going to have to find the third side. How you notice these are there is they give you a trig ratio and a quadrant, or a trig ratio and a restricted domain. So if I give you tan, just so you know, if I give you tan, I'm actually giving you a coordinate. Because what's the acronym for tan? Tan, your x box, which is actually an x and a y. And what is an x and a y? A coordinate. It's exactly like what we did when you get given a tan or a cotan, what we did before. It's in quadrant 1. Why did they have to say quadrant 1? Oh, poopy. What do I have to do? Why does it have to say quadrant 1? Where else could it be? Where else is tan positive, guys? Quadrant 3. So technically, these could both actually be what? Negative. Because what's a negative divided by a negative? A positive. So just because they don't have negative signs on them doesn't mean they can't be negative. But because it's in quadrant 1, we're going to end up drawing it here. Bow ties always, correct? Are you writing this? Okay. X is 5. Y is 4. I want you guys to find the third side, which is R. R is always what? R is always positive because it's a radius measure. And then you're going to do the three trig ratios. Go. So we find the third side. We get R squared equals 5 squared plus 4 squared. R squared equals 25 plus 16. R squared equals 41. When we take the square root with our hand, what do we have to remember to do? Plus, minus. And R always has to be positive, so we get root 41. I always fill in my triangle, and the people who draw triangles, 99.9% of the time will get this question correct. The ones who don't draw triangles will often miss the negative sign and get it wrong. Okay, this one didn't have a negative sign, so you need left. Okay, cos goes with cooked extra rice. So it's going to be 5 over root 41. Then we have to rationalize our denominator. And I get 5 root 41 over 41. Okay, and constant coffee. Cosecant goes with sine, correct? And sine is sine your resume. So this is resume your. Answer split, not angles. So that's going to be answer. It's going to be root 41 over 4. And then sine is sine your resume. So it's going to be 4 over root 41. And then we have to rationalize it. So we get 4 root 41 over 41. Okay. The next one is between 90 and 180. It did have a degree symbol, but it obviously got knocked out with a box. It needs to be between 90 and 180. Go. Quadrant 2. So they can give you quadrant 1 like this. Tell you what quadrant it's in. If they can give you a reduced domain, which gives you a quadrant. And this one it says quadrant 2. It's also sine is positive, so it's a good thing. Correct? And sine is sine your resume. So I gave you y and r. So I know y equals 3. I know r equals root 10. X is what I'm going to have to find. And because I drew it, I won't mess this up. But x is in quadrant 2, and so x is negative. So if you have the positive version of that, do you think the oopsies will be on the test where you take it as a positive instead of a negative x? Yep. That's why you need to draw it. Okay. So we get x squared equals root 10 squared minus 3 squared. X squared equals 10 minus 9. X squared equals 1. When we take square root, we do plus or minus. And in this case, it is negative 1 because I drew it here. That's why drawing it is so important. And the people who skip drawing often are in trouble because they don't draw it in the right spot, and often it's the minus sign you miss. Or you don't know if it's plus or minus, you just guess, which is never a good situation. All right. So TAN's acronym is TAN your Xbox, because we don't want it to have a vitamin D deficiency. So we get 3 over negative 1, which isn't wrong, but they'll often write as negative 3. Cosecant was a sign. Sign is sign your resume, so this is resume your. R is root 10, and Y is 3. And then cos is cook extra rice, so I'm going to get negative 1 over root 10. And then I have to rationalize my denominator, which means get rid of the radical. And so I get negative root 10 over 10. There's 2 on the top of the next page. See if you can figure it out. It doesn't give you the quadrant directly, but you can use CAST to figure out what quadrants it is in. It's going to be my hint. So for 3 and 4, you have to use CAST. You're going to use whether the first trig ratio is positive or negative, and then it tells you where the next thing is positive or negative, and you can find. So for example, everyone watching, if I gave you sine theta equals 2 over 7, right? And then I said tan theta is less than, we'll say greater than 0, and we'll say this is negative. What quadrant could this be in? I technically need negative sign, because that's the answer is negative. And what does this mean? Positive tan. So using CAST, or all students take calculus, where is that going to happen at? So that one would be here, right? Yeah? Okay, try 3 and 4, go. So here we have sign your resume. There's a negative sign sitting in front. Does it have to go with the Y or the R? The Y. In this case, there's no option. If it's X or Y, it could go to the top or the bottom, so you can find out what quadrant it's in, correct? But R can never be negative, so the Y is going to have to be negative and the R is going to have to be positive. So we need where this is sine negative, so negative sine theta, and then positive tan theta. It needs to be greater than 0. So sine is negative, and tan is positive in quadrant 3. It's going to be here. So we have Y equals negative 2. We have R equals 3. And we have to find X equals negative something. I drew it so I know X needs to be negative. So I'm going to have X squared equals 3 squared minus negative 2 squared. X squared equals 9 minus 4. X squared equals 5. Square root, plus or minus. So it's going to have to be negative root 5. And it needs to be negative because we know it's in quadrant 2 or quadrant 3, and in quadrant 3, X and Y are negative. Paying attention? Okay. Then cos is cook extra rice. So we're going to get negative root 5 over 3. Cosecant goes with sine. Sine is sign your resume. So this is resume your. So I'm going to get 3 over negative 2, which I can write like this. I can write like this, or I can write like that. They're all the same. As long as there's only one negative sign, right? Because those would all give me negative 1.5. And then cotan, tan your Xbox, so cotan is Xbox your, answer split. So we're going to get negative root 5 over negative 2. What happens when you have a negative divided by negative? They cancel, and it should be positive because cotan and tan are positive in quadrant 3. So you get root 5 over 2. Then this one, cook extra rice. So I know we have cos negative, so negative cos theta. And we have negative tan theta. Where is cos negative and tan negative? Quadrant what? 2. Because the only thing positive in quadrant 2 is sine, right? So that means cos and tan are negative there. So I know I have x equals negative 5. I know I have r equals 13. And y equals positive something. Now, remember with 3, 4, 5, that was a nice perfect triangle that we did before when we got a 3 and a 4. 5 was the radius. This is another nice one that doesn't turn into radicals. It's 5, 12, 13. So they use them sometimes. So we're going to get y squared equals 13 squared minus negative 5 squared. Y squared equals 169 minus 25. Y squared equals 144. Square root. Plus or minus. Can you guys stop talking, please? Y equals 12. All right. Then we have sign your resume. So I get 12 over 13. Secant goes with cos, cook extra rice. This is rice extra. So it's 13 and negative 5, which I could leave like this. I could write it like this. Or I could write it like this. And then tan your x plus. So it's going to be 12 over negative 5. Which is negative 12 over 5, which equals negative 12 divided by 5. Yeah? Okay, now I need your unit circle and your formula sheet handy for the next question. What do we know about the unit circle? It goes Calgary Stampede, correct? So it gives us the answers to cos and sine. Yes? Oh, wait. So, can you guys help me out here? On the inside of your circle, you have angles, correct? You are not allowed to flip angles. You flip answers. You don't flip angles. I would write that on my little unit circle at the very top. Flip answers, not angles. The top of my unit circle, I would say flip answers, not angles. So we are always flipping the answers on the outside, but never the angles. And this is a case of where I tell you that I need you to understand what the heck that unit circle gives you. It gives you cos and it gives you sine. So actually the unit circle gives you the x, y, and r of every single angle, correct? Because cos is cook extra rice and sine is sign your resume. So it actually gives you everything. So if we looked at the unit circle, everyone paying attention, so this makes sense. If I look at the unit circle and I just look at 30 degrees, yeah? At 30 degrees, it has root 3 over 2 and 1/2. This is why the denominators are always the same number. The denominators are both r, correct? This is cos, so it's x over r, y over r. I have my x, my y, and my r. Okay? So this is the answer to cos of 30 degrees. And this is the answer to sine of 30 degrees. True? So this is technically x over r. This is technically y over r. So can I quickly get secant of 30 and cosecant of 30? Secant of 30 and cosecant of 30. If this is x over r, root 3 over 2, what would secant be? You just rationalized it all in your head. Yes, it would be 2 over root 3. It would flip, and then we'd have to rationalize it. Because this is an answer, correct? The angle is 30 degrees. The angle is pi over 6. I'm not switching those. I switch answers. Because this is x over r, and r over x is that flipped. Correct? So secant would be 2 over root 3, and then Luke rationalized it right away. And you get 2 root 3 over 3. Cosecant, I would take my sine, which is y over r, and I would flip it, correct? Because it needs to be r over y. So 1/2 would become 2 over 1 or 2. Yeah? So we are going to go through and do the secants, cosecants, sines, and coses. We'll leave the tans for now. We will come back to them. So I'm going to do B, C, and D. You guys aren't going to touch A for now. Don't cross off the tans or cotans. We're going to touch those in a second. I don't want to overwhelm. Okay? So let's look at cosecant 7 pi over 6. Now, question. And the reason why I'm asking this is it's not my first rodeo, and I know what bad things you guys choose to do. 7 pi over 6. Is that an angle or an answer? It's an angle. Because it goes cosecant what? If I don't have this here. What is this? Cosecant theta. It's cosecant theta, is it not? What is theta? An angle. Correct? So an angle always goes beside here. Yes? So do I flip angles? No. I'm going to go to the answer there and flip it. Yes? So cosecant goes with what? Sine. So I'm going to go find that up here first. So I always go sine of 7 pi over 6, and I find the answer to that first. 7 pi over 6 is in quadrant 3. It's the radian measure of 210 degrees. Sine is x or y? Calgary? Stampede. So it's what? So what is the y at 7 pi over 6? I think it's -1/2, is it not?
Yeah, it is.
So you go to the y at 7 pi over 6. What is the y at 7 pi over 6? -1/2, correct? And that's technically y over r, is it not? Do we agree? So what would cosecant of 7 pi over 6 be? 2 over -1, which is -2. We flip the answers on the outside of your unit circle. We never flip the middle. Okay? So you find its bestie, and then you flip it. So cosecant's bestie is always sine. Secant's bestie is always cos. And then you flip it because they're called reciprocal trig identities of each other. Reciprocal means flipped. All right, sine of -300. As much as I love -300, I like its coterminal angle better. How do I get its coterminal? -300 what? Plus 360. So it's going to land on 60. So guess what? Sine of -300 is equal to sine of 60. Because they terminate on the same coordinate. Yes? -300.
Turn forwards for 1 second.
So -300, I would go clockwise, correct? I would go -90, -180, -270, -300. Yeah? It's also the same as 60. They land on the same things. They have the same answers on the outside, yes? -360 terminate on that same dot. Same coordinate. Does that make sense? We was at our 360s. We need sine. Calgary Stampede. Which one is sine? X or Y at 60? Y. What is Y at 60? √3 over 2. So technically, if I went sine -300 in degree mode in my calculator, or I went sine of 60 in degree modes in my calculator, I would get 0.8660, which is √3 over 2. I can check these, correct? Okay. Secant of 60. What do I need in order to do secant of 60? Cosine of 60. What is cos of 60? 1/2. And that's extra rice, correct? So what is secant of 60? Rice extra, which would be 2 over 1 or just 2. Okay, say I want to check secant 60. Your brain falls out of your head. You're like, Lepp, I do not have a secant button on my calculator. If you're like, I am lost, where should you maybe go that could help you? Starts with an F. Rhymes with formula sheet. Formula sheet. Not pretty big. Formula sheet. The rest of you, no one answering. No one answering. But I'm hoping that in your heads you're thinking. Formula sheet. So go to your formula sheet, and I don't know how to type in secant. Do you see this? It shows you secant theta equals what? 1 over cos theta, right? So if I want to type secant 60 in, I'm going to write it here to help myself out. If I want to type secant 60 in, I type in 1 over cos of theta. What was the theta in this case? What is my theta? 60. Hold my land. Remember, when it opens, every single time you press cos, it's going to open a bracket, close a bracket on it. So 1 divided by 60, go. Undivided by, cos of 60. What mode do you need to be in? Degree mode. Because the moment you go to press cos, sine, or tan, you have to slap your little hand and be like, what mode do I need to be in? I was aggressive, that actually kind of hurt. Say degree. The answer is 2. 2. It confirms you're correct. Or if you stink at putting these in, it makes you feel real wrong. But it might just be your calculator skills. Okay? You are not. All right. I want you guys to try EFG. Can't do H yet. It's a tan. EFG. Go. So I want you to do this one. Oops. This one. This one. This one. This one and this one. Try that one. See how you do. And then these. Cos of 150 is x at 150. What's x at 150? Negative root 3 over 2. Okay, sine at 315 is the y at 315, which is negative root 2 over 2. Remembering, we could check these in our calculators, correct? Negative 30, I could just follow it down 30 degrees and it lands on 330. But if that's hard for you to visualize, you can go negative 30 plus 360 and say, oh, that's the same as 330. So I would go equals sine of 330. What is sine at 330?
Negative 1/2.
All right. Cos squared 225. Everyone paying attention? They throw the squared in the middle because if the squared was here, it would be affecting the 225, and that is not what we want. The squared in the middle is a problem for your calculator, though, because the moment you press cos, it slaps open a bracket on you. You throw the 225 and you close the bracket, correct? So there's no place to put the squared in on your calculator. So when you go to do calculus next semester, and you go to do derivatives with chain rule, you need to remember that the squared in the middle goes completely on the outside. So I will always rewrite this, especially in calculus. I will rewrite this as, not with an eraser, I will rewrite this as cos 225 because your calculator is going to open this bracket, you're going to close it, all squared. So it literally wants the answer to your answer and squaring it. That's all cos squared 225 means, okay? So you're going to have to write it like this in chain rule, because in chain rule, you're going to drop the 2 in front, rewrite this to the 1, and do the derivative of the inside. If you don't rewrite it like this, calculus, derivatives, for trig, it's going to be a bit difficult for you. So always rewrite it. Okay. Cos of 225. What's your answer? Negative root 2 over 2, and then I have to square it. So I square the negative, it becomes a positive. I square a square root. It becomes 2, it just goes away. And then I square the 2 and I get, so my answer becomes 1/2. Okay, sine 5 pi over 3 lands you in quadrant 4. 60-degree reference angle. And it's y, so it's negative root 3 over 2. Okay, cos negative 2 pi over 3. You could envision negative 2 pi over 3 going counterclockwise to 2 pi over 3. Or sorry, clockwise, not counter, sorry. Or you can find the coterminal. So I would get negative 2 pi over 3, and I want to add 2 pi to it. The catch is I need a common denominator, correct? So I need this to be over 3, which means I need to multiply this as well by 3. So I'm going to get negative 2 pi over 3 plus 6 pi over 3, which is 4 pi over 3. So I get cos of 4 pi over 3 is coterminal with cos of negative 2 pi over 3, which makes sense. So if I go to 4 pi over 3, I'm going to go counterclockwise all the way to 4 pi over 3. 4 pi over 3 is same as 240. If I go negative 2 pi over 3, I'm going to land on 240 because negative 2 pi over 3 is negative 120. Lands on that same arm. Yes? Either way. So, what is cos at 240? Negative? This was a 1. 2 pi. I knew not writing the 1 was going to lose half the people, but I brought it back. Sorry, that was my bad. So it's negative 1 over 2. Sine of negative pi is the same as sine of pi, because it's 0 to negative pi, correct? Or we can add 2 pi to it. Negative pi plus 2 pi equals pi. So this equals sine of pi. What is sine at pi? What is y at pi? 0. Then negative 5 pi over 3, although it's lovely, is negative. So I'm going to go negative 5 pi over 3 plus 2 pi to get it to be positive. Then I need a common denominator in order to add them. This is over 1. Ooh, that's aggressively. And I'm going to times this by 3, because when I do the bottom, I have to do the top. And so I'm going to get negative 5 pi over 3 plus 6 pi over 3 equals pi over 3. So it's the same as cos at pi over 3, which equals, what's x at pi over 3? 1/2. So off my unit circle, I can take cos and sine really quickly, correct? I can also take cosecant, secant really quickly. It's just the cos and the sine flipped, correct? The answer's on the outside. Yes? Do you agree? Tan, we have to use our top two formulas. So if you look at the formula sheet, not that one random one at the top, but these two formulas. So we have tan theta is sine over cos, and cotan theta is cos over sine. Do you see that? Do we have cos and sine already? We know what those are. They're in the unit circle, yes? So we're going to get stacked fractions. So let's go back up to the top. We'll deal with the tans. Okay, tan of pi over 2 is the same as sine of pi over 2 divided by, cos of pi over 2. I will lose you. We're all paying attention, right? Sine and cos come off of our formula sheet. Instead of tan, what if we had cotan? What would we do? What's the formula for cotan on the formula sheet at the top? Cos over sine. So it's the exact, you would just have cos pi over 2 and sine pi over 2 if I asked you for cotan of pi over 2. That's it. Go to your formula sheet, right? Like if you're ever stuck, your formula sheet gives you some answers. So what is sine or y at pi over 2? What is y at pi over 2? Go to pi over 2, which is 90, and look at it. What's the y? 1. What's the x? 0. Can we divide by 0? No, this is actually undefined. So cotan and tan end up undefined at the arms because, or 0. So 1 over 0. So if I did tan of pi over 2, it's undefined. But cotan of pi over 2 would actually be 0. Because these would flip, it'd be 0 over 1. Let's try tan of 240. Tan of 240 equals sine of 240 degrees divided by cos of 240 degrees. What is sine of 240?
Negative root 3
Negative root 3 over
pi over 2.
2? Divided by negative 1/2. Now I told you about stacked fractions. If things can cross off in the numerators, you can do it. If things can cross off in the denominators, you can do it. Because when you divide fractions, it's actually this divided by this. So if you don't want to show that step where you take this and multiply by this, the flip of it, you can just cancel off if denominators are the same. So is there anything the same in both numerators?
Negatives.
There's negatives, so they can become positives. But root 3 and 1, there's nothing I can cancel, right? This denominator has a 2, this denominator has a 2. So what can I do with them? So the denominators become 1s. So do I care about them anymore?
Nope.
Nope. So my answer is going to be root 3 over 1, which is just root 3. You guys are going to try I, L, and P. Go. Degrees. I'm going to do 480 degrees minus 360 degrees. Gets me 120 degrees. So I'm going to get tan of 120 degrees. As much as I like that, I like cosines and sines. So I'm going to do sine 120 degrees divided by cos of 120. Sine at 120 degrees is positive, what? Root 3 over 2. And cos of 120 is negative 1/2. The 2's cancel. And I'm left with root 3 over negative 1, which is negative root 3. Tan of 7 pi over 6 is the same as sine of 7 pi over 6 divided by cos of 7 pi over 6. Okay. Sine of 7 pi over 6 is negative 1/2. Cos is negative root 3 over 2. The 2's cancel, the negatives cancel, and I'm left with 1 over root 3. And then I still need to do what to it? Rationalize it. Please be quiet. Times root 3, and I get root 3 over 3. Okay, then we're going to do P. So this one I'm going to have to do sine 2 pi over 3 divided by cos of 2 pi over 3 all squared. Sine of 2 pi over 3 is root 3 over 2, right? Yes. Cos is negative 1/2. Squared, cancel, cancel. I get negative root 3 squared, which is 3. You guys have the ability to do 1 to 6 in your homework. Number 1 asks for a principal angle. You won't be able to do the principal angle until tomorrow. Can you take your homework sheet out for a second? Because I'm restricting the domains nicer on number 3. So 3A is fine. 3B, 4.3. You guys are able to do 1 to 6 on 4.3 now, except for number 1, principal angles. So B is going to be cos theta, negative root 2 over 2 with 3. That stays the same. Guys, you listening? That stays the same, but then the restriction behind it is way more difficult, so I'm going to be nice and go tan theta is less than 0. So it's this part that changed. Take off the restricted domain and say that. For C, you have tan theta equals 2 over 3. That didn't change. But what I want you to change the restricted domain, I want to be sine theta is less than 0. So this is what changed. And then for D, A didn't change at all. D, I want secant theta, or root 3 over 3. I want to change to cotan theta is greater than 0. This case. So cotan's positive.